All right, guys, so this is our first lesson on radicals, also called square roots. So if you would please get that worksheet out. All these examples that I'm going to do are on the worksheet, and you can just write on the worksheet, or if you like to organize it a little better, you can write it on your own notebook paper, whichever. But I'm just going to teach this like you've never learned it before, and there's several ways to do this. So if you know how to do it and you've learned it a different way, please by all means don't change to do it the way I do it the way you're comfortable with. But I like to teach it. It's called the cake method, and to me it's by far the easiest way to do it and the less likely to make a mistake. All right, so first of all, we want to talk about what is a radical, or what is a square root. Okay, so a square root is basically the inverse of squaring a number. Okay, remember inverse is like the do and the undo. So like the inverse of add is subtract, the inverse of multiply is divide, to do and undo. So I could say that the square root of 9 equals 3 because 3 squared equals 9. Or the square root of 25 equals 5 because 5 squared equals 25. So basically, what number times itself is equal to 9. All right, so let's look at example number 1. This is the square root of 8. Okay, so I'm going to bring you back to the first several prime numbers. Okay, now remember, prime numbers is a number that is divisible by only 1 in itself. Okay, so if you remember, 1's not considered prime, 2 is prime, 3 is prime, 4 is not because 2 times 2 is 4, 5 is prime, 6 is not because 3 times 2, 7 is, 8 is not, 9 is not, 10 is not, 11 is, 12 isn't, 13, 14 no, 15 no, 16 no, 17 is, 19 is, 21 is not, 23 is. That should be enough. Okay, so here's the first, I don't know, 10-ish prime numbers. And you will need these prime numbers to simplify this radical, or this square root. Okay, so what I'm going to do is I'm going to break the number 8 down into its prime factorization. So you can remember probably in like 5th or 6th grade when you did a number tree where you had 8, then you had, 4 and 2, and then you had, 4 goes to 2 and 2, and then you circled all of them, and you said, well, 8 equals 2 times 2 times 2, which equals 2 to the 3rd. Okay, so we're basically doing that, except we're going to do it in a more, in a method better to follow, I guess. All right, so we're going to start with 8 here. Okay, and now we're going to break 8 down into its prime factorizations. Okay, so I'm going to look at these numbers here and I could say, well, what, if any, of these is 8 divisible by? Well, 2 can go into 8, so I'm going to say 2. Okay, so 8 divided by 2 is 4. I'm going to put the 4 here. Okay, so then which one of the prime numbers can go into 4? Well, that is 2. Okay, so 4 divided by 2 is 2. Okay, what prime number goes into 2? Well, 2 does again. So 2 divided by 2 is 1. When I get to 1, I'm done. Okay, 1, I'm done. Okay, so basically what I said here is that 8 equals 2 times 2 times 2, which is true. Now if 8 equals 2 times 2 times 2, then the square root of 8 equals the square root of 2 times 2 times 2. And when we have square roots like this, we can break them apart. The same thing as, and you don't have to write all this down, I just want you to understand what we're doing. the same thing as square root of 2 times square root of 2 times square root of 2. Or if we put these together, square root of 4 times square root of 2. Okay? Well, square root of 4, guys, is 2. Okay? So 2 comes out front. We can drop the square root under this because this is just equal to 2. But we're left with square root of 2. So what I'm going to do is I'm going to go back to right here. Okay, so I'm going to go through and I'm going to circle my pairs. Well, I have a pair of 2's and I have a leftover 2 that doesn't have another 2 to be paired with. Okay, so I can say pairs go on the outside and I'm going to say leftovers go in the fridge. And what I mean by that is this pair here goes on the outside as a single 2. Leftovers, which is right here, goes in the fridge. So square root of 8 simplifies to 2 square root of 2. All right, so let's look at example 3. We're starting with 384. Okay, and once again, I want only prime numbers here. Okay, so what's a prime number that goes into 384? And you don't have to go in any specific order. Okay, I know 3 goes into 384. Okay, so 384 divided by 3 gives me 128. Okay, well, I know 2 goes into 128. 128 divided by 2 is 64. Okay, 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 goes into 2 once. When I get to 1, we're done. All right, now I have my prime factorization of 384. It's 3 times 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, so I'm going to go through and I'm going to circle my pairs. So I have a pair of 2's, and I have a pair of 2's, and I have a pair of 2's. And I can't pair these 3 and 2 because they're different, so I have a leftover 3 and a leftover 2. So remember, pairs come out front, and then leftovers go in the fridge. Okay, so pairs come out front. So notice I have 3 pairs. Now each of these come out as just a 2. Okay, and when I have more than one, I'm going to multiply them. So I'm going to say 2 times 2 times 2 is out front. And then when I have multiple leftovers, I multiply them as well. So I could say 3 times 2 in the fridge or under the square root. Well, guys, 2 times 2 times 2, 2 times 2 is 4, times another 2 is 8. Square root of 3 times 2 is 6. This is my simplified answer. All right, let's look at example number 9 now. All right, so example number 9 is the square root of 210. Okay, so I'm going to break 210 down into its prime factorization. Well, I know 3 goes into it. 210 divided by 3 is 70. I know that 7 is prime. And 7 goes into 70 10 times. 5 goes into 10. And once again, it doesn't matter the order of these. 5 goes into 10 twice. 2 goes into 2 once. When I get to 1, we're done. Now notice all of these numbers are prime. Okay? If I look at these, none of them have pairs. I have one of each of these. Therefore, nothing comes out front, so I'm just left with leftovers. So 3 times 7 times 5 times 2, which is 210. So all that means is this square root of 210 that we started with, it just can't be simplified. All right, go ahead and try number 15 on your own, and then we will go over it. All right, so when you break 392 down into its prime factorization, you should have gotten 7 times 7 times 2 times 2 times 2. Okay, so you can pull one pair of 2's out and the pair of 7's out. So 7 times 2 comes out front. Your leftover is right here, which is just 2. 7 times 2 is 14, square root of 2. So this should be your final simplified answer. All right, so let's turn the page, and these aren't any more difficult. There's just one tiny extra step, but it's not that big of a deal. All right, so what this is this is the same thing as saying -5 times the square root of 294. Okay, when there's nothing here, think of that as multiply. So all we're going to do is we're going to focus on the square root of 294 first. Okay, so we're going to break down 294 just like we would before. Okay, so 294, 3 goes into it. 294 divided by 3 is 98. 2 goes into 98 49 times. Prime number that goes into 49 is 7. 49 divided by 7 is 7. And then once again, 7 goes into 7 once. When I get to 1, we're done. So the prime factorization of 294 is 3 times 2 times 7 times 7. Okay, now I'm going to go through, I'm going to circle my pairs. Well, I have a pair of 7's. This 3 doesn't have another 3 to go with it. 2 doesn't have another 2 to go with it. So those are leftovers. So the pairs come out together in the front. So I just have one pair of 7's in the front. Square root of, when I have more than one left over, I multiply them. So 3 times 2, which just simplifies to 7 square root of 6. Okay, but that's just square root of 294. Okay, so I'm going to take -5 times, and I'm going to substitute 7 square root of 6 in here. Okay, well, here all we do is multiply what's on the outside together and what's on the inside together. Well, we just multiply these two together. -5 times 7, -35. Square root of, I don't multiply this -5 times 6 because it's not in a square root. So this is just square root of 6. So our final answer is -35 square root of 6. All right, the last one we're going to do is 39 before you do your homework. Go ahead and try this one on your own and then we'll go over it. All right, so -4 times square root of 54. So I'm going to take square root of 54 by itself, and I'm going to break it down over here. So square root of 54, or 54 in its prime factorization is 2 times 3 times 3 times 3. So we have this pair of 3 right here, and 3's come out front. And then the 2 and the 3 are leftovers, so they go inside and we multiply them. So square root of 54 is the same thing as 3 square root of 6. Okay, so I'm going to substitute square root of 54 with 3 square root of 6, and then I'm just going to multiply it by a -4. And remember, whatever's on the outside gets multiplied together, whatever's on the inside gets multiplied together. So -4 is on the outside, 3 is on the outside, so -4 times 3 is -12. There's only a square root of 6 on the inside, there's not another square root, so it's just -12 square root of 6, and this should be your final answer. All right, your homework is numbers 2 through 40 evens. Okay, that seems like a lot, I know, but after you do a few, they'll get going pretty quickly and it won't take you very long. If you get stuck, let me know.